All right, welcome to the Explainer. Today, we are going to tackle something that is absolutely fundamental to cloud networking. We're talking about AWS Subnets. So let's just start with the big picture, right? The cloud. It's this huge kind of open space. So how do you carve out your own private, secure corner for your applications? I mean, how do you actually build that fortress to protect your most critical data? Well, the answer. It all starts with this one simple but really powerful building block. Think of it as the foundation for your entire virtual data center. It's literally the first stone you lay down to build that secure space we were just talking about. And that building block, it's the subnet. Now, the official definition is, a range of IP addresses inside your virtual private cloud, your VPC. But what does that really mean? It's the neighborhood where your servers, your databases, all your stuff actually lives. Okay, this is the best way I found to think about it. Imagine your VPC is this entire private office building that you own. A subnet? That's a secure locked room inside that building. Simple as that. And listen, these rooms are for way more than just keeping things tidy, though that's a nice bonus. No, they are absolutely crucial for controlling the traffic flow, who and what gets to move around your network. And that right there is the secret sauce for both security and for building apps that don't fall over. There's another really cool thing about this design. It has a massive impact on making your application resilient. See, AWS has this rule. A single subnet has to live completely inside one physical data center, what they call an availability zone. So what you do is you put copies of your application in subnets spread across different availability zones. That way, if one whole data center goes down, peef, no problem. Your app just keeps on running. Okay, so back to our office building analogy. Not all the rooms are created equal, right? Some have big windows looking out onto the street, and others are secure, windowless rooms deep inside. And that brings us to probably the most important distinction you need to understand about subnets. It's this: public versus private. The difference couldn't be simpler, really. It all boils down to one question: can it talk to the public internet? Public subnets, they have a direct line out, perfect for your web servers. Private subnets, on the other hand, are totally isolated. They're the secure vault where you lock away your databases, your back-end code, all the sensitive stuff. And this right here, this is a core security principle in action. Your web server, it's sitting there in the public subnet, talking to all your users on the internet, but it's also playing goalie. It acts as a gatekeeper, and it should be the only thing that gets to talk to your database, which is safe and sound, tucked away in that private subnet. And hey, don't just take my word for it. This isn't just, a good idea I came up with. This is the official, straight from the horse's mouth recommendation from AWS themselves. If you want to keep your valuable stuff secure, your default move should always be to stick it in a private subnet. End of story. So you might be wondering, how does a subnet even know if it's public or private? Like, how does it know where to send all its data? Well, the answer is all about the signs that direct traffic down the hallways of our virtual office building. See, every single subnet has to have this thing called a route table attached to it. Just think of it like a little GPS for your network traffic. It's a list of rules that tells every single packet of data leaving the subnet exactly where it's allowed to go and where it isn't. Okay, let's take a look at a really simple route table for a public subnet. That first line, the one with 10.0.0.16, that's just saying, hey, if you're trying to talk to someone else inside our own network, just stay here. It's the local traffic. But that second line, oh, that's the one that changes everything. Yep, that 0.0.0.0/0 route, that's the whole ballgame. That's just tech speak for literally anywhere else on the entire internet. So this rule is the big sign on the wall pointing to the main exit door, which in AWS is called an internet gateway. And here's the kicker. A private subnet's route table, it just doesn't have this line. That's it. That's the only difference. Okay, so we've got our rooms built. We've got the signs on the wall telling traffic where it can go, but now we need to add some locks to the doors, because just because there's a path somewhere doesn't mean we should let just anyone walk through it. And this is where AWS gives you what's called a defense in depth strategy. It's not just one lock. You get two different kinds of firewalls that work together, protecting you at different levels. It's all about layers of security. So layer number one is the network ACL. The best way to think of this is like a security guard posted at the door to the entire room, the whole subnet. This guard checks the ID of every single packet trying to get in or out. It's the bouncer for the whole subnet. Now, the second layer gets way more specific. This is the security group. Instead of a guard at the room door, think of this as a personal bodyguard standing right next to your server or your database. It's a firewall that's attached directly to the resource itself, checking traffic right at the last second. Now, if you remember one thing about these two, remember this: the difference between stateful and stateless. Security groups are stateful. What that means is, if you let traffic in, it automatically remembers that conversation and lets the response go back out. It's smart and it's convenient. Network ACLs, on the other hand, are stateless. They have no memory. This means you have to write separate rules for traffic coming in and for traffic going out. It's more work, sure, but it's also way more powerful because it lets you create explicit deny rules, like blocking a specific bad IP address from ever even getting to the door. All right, let's put it all together. We've talked about the rooms, the signs on the wall, and the locks on the doors. So now, let's see what the final blueprint for a really secure application actually looks like. So, step 1, we start with our big empty VPC, our office building, and the very first thing we do is divide that space. We create a public area for anything that needs to talk to the internet and a private, secure area for our backend. Step 2, we install the main door to the outside world. That's our internet gateway. And this is so important. We use that route table, our set of signs, to make sure the path from that door only leads to the public subnet. There's no path from the internet to our private areas. And finally, step 3. We place our equipment in the right rooms. The web server that needs to talk to customers, it goes in the public subnet. The database with all our precious data, it goes deep inside the private subnet, where the only thing it can talk to is our web server. And that, my friends, is the classic, rock-solid, secure cloud architecture. So there you have it. This setup is incredibly secure, it's robust, your data is finally safe inside its fortress, but it does bring up one little problem, doesn't it? What happens when that private database needs to go out to the internet to download, say, a critical security update? How can it do that if we've completely walled it off? Well, that's a great question, and it's a story for another time.